Hurricanes with their devastating winds and flood-causing rains, a perennial threat. In 1969, Hurricane Camille was first observed and then tracked by satellite. Because the storm's arrival was predicted accurately enough in advance, it was possible to evacuate people from the Gulf Coast. Without this early warning, the Weather Bureau estimated that 50,000 people might have been killed. In contrast, during Hurricane Laurie in November 1969, observations and tracking by satellite enabled the weather forecasters to predict that Laurie would not strike the coast. It is estimated that $3 million was saved from this satellite-prompted decision not to evacuate and not to protect property. TIROS, Television Infrared Operational Satellite. Over the past 10 years, 20 of these hatbox-shaped satellites have been successfully launched for use by NASA and the Weather Bureau. The television eyes of TIROS scan the entire globe daily, reporting on cloud cover and warning of major storms. Since the first operational weather satellites started clicking off pictures, roughly 600 severe storms have been detected, followed, and predictions made about their course. They have sent back more than 1 million pictures of weather conditions around the globe. Cameras on board the Applications Technology satellite scan the Earth and return color images as often as every 20 minutes. Here's a view showing 6 hurricanes on one picture. This near continuous surveillance of 40% of the Earth's surface has proven so useful that the reports have been incorporated into routine weather forecasts and have pointed the way for even more sophisticated meteorological satellites. Major airlines make use of satellite data in planning their flights. Pilots routinely receive weather photos of their transoceanic routes. Before satellite tracking of hurricanes, U.S. Navy hurricane hunters had to search out the killer storms. Weather satellites now locate the storms, and the Navy flies directly to them to make their measurements. The Navy also uses weather satellite pictures for ice patrols. Remote stations in the Antarctic benefit too. Giant resupply ski planes can be safely scheduled for landings in the icy outposts without worrying about being trapped by snowstorms. Supply ships benefit from improved scheduling as well. A recent satellite in the TIROS series does the work of 2 spacecraft. Carrying twice as many cameras, it's capable of discerning cloud formations as small as 2 miles across. The improved TIROS operational satellite carries a proton monitoring instrument that helps spot solar flares. The same instrument can measure the amount of heat reflected from and absorbed by the Earth's atmosphere. This is very important in weather forecasting. In addition, radio frequencies affected by solar storms can be changed in advance, and manned flights to the moon better planned. Nimbus, research and development craft studying advanced techniques and concepts for meteorological Earth observations. Nimbus is measuring the atmosphere's temperature and moisture at various altitudes, as well as making day and nighttime cloud photographs. These measurements are considered the key to accurate long-range weather forecasts. By the end of this decade, forecasts made 1 week in advance will be as accurate as those now made 24 or 48 hours ahead. Satellites and weather are global in nature. Every nation in the world can benefit from the automatic picture transmissions of U.S. weather satellites. Over 50 countries are now using inexpensive automatic picture readout equipment to view daily weather patterns over their own territory. These same countries